Okay, let's go ahead and take a look at those poker hand problems. There's a lot of these. There's a lot of these, I think, in the first homework, and I want you to be sure to try to work through 11.1 and 11.2 over the weekend. So I thought we could just work through these. I kind of rushed this at the end of class. So the four that I have circled are pretty reasonable, straightforward. I really don't think you'd have too much trouble if you understand what the chart is trying to say. So in the chart, what they have, they're saying that if I pulled 5 cards out of a standard 52 card deck, that there would be 2,598,960 different not arrangements, that many different collections of 5 cards. Okay. So, and then all the different ones are classified according to whether they're a full house or a flush, that sort of thing. And so when you see that there's, for instance, 5,188 hands that turn out to be a flush means all the same suit. Okay, they've counted all of those up. Okay, that's different than these. All right, what I'm trying to get at is the numbers that you see in the chart. A 5-card hand will only go in one place in this chart. There's no overlap. So when they talk about flush down here, the flush that they're talking about is 5 cards all of one suit, but not a straight flush, not a royal flush. Okay. All right. So there's no overlap. You don't have to worry about things being double counted. When you do something pretty straightforward, like what's the probability of being dealt a hand that turns out to be a royal flush, it is just looking for the number of possible royal flushes. There's 4 out of the total number of 5-card hands, which would be this. And then in this problem, they ask for it rounded to 6 decimal places. So what you're going to do is type in 4 divided by that number, and that's going to give you a decimal, and the decimal is going to be kind of long and messy. This one has 5 decimal places and then a 1, 5, 3, 9. They want it rounded to 6 decimal places, so you count out 1, 2, 3, 4, 5. 6 would be here. You look at the place after that, and because it's 5 or bigger, you're going to bump that up. Rounding is trying to tell me whether it's closer to 0.000001 or 0.000002. So because it's more than halfway to the next one, you would round it and you would have put this in. And that would be approximately the probability for getting a royal flush. Now, we can tell why there's only 4 royal flush hands. A royal flush means it has to be 10, jack, queen, king, ace. And it has to be all the same suit, and there's just 4 suits. So there's only 4 possible hands. But on the others, it's a little harder to figure out where their numbers came from. Okay, so for 4 of a kind, you're just going to put 624 out of all the possible hands. And then you're going to divide that out. And when you do, let's see, I need this to be spread out a little bit more. Well, so that goes with that first one. Okay, you're going to divide that out. It's going to turn out to be approximately 0.123240096 is what I saw in my calculator. So 1, 2, 3, 4, 5, 6 places would be here. It's a 0 after it. So you would put in 0.000240 is what you would put in. Okay. So that's the 4 of a kind one. All right, we're going to skip the 4 4s and the clubs flush right now. We're doing the ones that are straightforward. All right, now when they say flush or one pair, okay, so the flush would be 5108. The one pair would have been 1,098,240. Flush or one pair, okay, it could be either or both. So you would add those two and put that over the 2,598,960. Okay, so when you work that out, you wind up with, I didn't write what that turned out to be when I added, but I did write out what I got after my decimal. Make sure you hit enter after you add those two together. Make sure you hit enter before you divide, and you'll get 0.424534429 about, and that would be 1, 2, 3, 4, 5, 6. So that's the sixth place. I look at that one. It's less than 5, so I would put 0.424534 into the calculator. Into the computer. Okay. All right. And then let's look at not a 4 of a kind. So earlier we did 4 of a kind. So not a 4 of a kind should be 1 minus that is one way to think about it. So if you've already done 4 of a kind, not a 4 of a kind should be 1 minus that. But we also could have thought, well, there's this many hands. Okay, so I'm doing this one right down here. So there's this many hands, and you want it to not be a 4 of a kind. So we'll subtract 624 from that. And that'll get all the hands that aren't a 4 of a kind. I could have also added up all these spots other than the 4 of a kind, but you see how it's quicker to think, let me get all the hands and subtract the 624. Now, when you do that and work it out, it's going to be a pretty big number because we're only taking 624 out of that. So it turns out to be 0.99975, and I think it was 9904. Okay, when I did it. And then I looked at 1, 2, 3, 4, 5, 6 decimal places, and what's after it was a 9, so that bumps that up and makes it a 10, which means I have to bump that up and make it a 6. That was a little tricky on the rounding part of it. So it's 0.999760 is what you would put in. Okay. All right. So those are the more straightforward ones. The ones that you might be asked that are kind of tricky are, what about getting 4 4s? Okay. So that's like a 4 of a kind, right? So you might be thinking, well, it's just 624 over all of that. Okay, but you're looking for specific 4 of a kind. You're looking for one that's composed of just 4s. So you have a 1 out of 13. It's like this would be all the 4 of a kind hands that are possible. And you want to then extract from that the 4 of a kind hands that are composed of just 4s. And a 4 is one of 13 cards, right, in each suit. So I would really be thinking this, well, there's 4 4s in the 52 cards. Okay. I really need to multiply by, that's the same as multiplying by 1/13. 8960. That idea right there. See, what that's doing is that's taking the 624 and it's pulling out of all of those 4 of a kind hands just the ones that are composed of 4s. Okay, so you do that 1/13 of that, and when you do that, you wind up getting 0.000018469 is what my calculator showed, and then 1, 2, 3, 4, 5, 6. It's got a 4 after it, so I would have put in 0.000018. Okay, and then a clubs flush is kind of like that. For a clubs flush, I'm thinking about how a flush, let's see, the flush is 5108. There's 5,108 hands that turn out to be flushes out of this total number of 5 card hands. Okay. But then when you think about it, clubs would be one suit out of 4. So what I want to do is I want to take this, and when you think about it, there's 4 suits. And so it's like you want to take only a fourth of that 5,108 because you want only the ones that are made up of clubs. So you multiply 1/4 by that, and you wind up with, let's see if I can keep straight where I'm at. You wind up with about 0.123049135, and that simplifies, rounds to be, so this is the 6, rounds to be 491. Okay, and that's what I would put in, is the 6-digit rounded one. Okay, so I wanted to just do that again. I did it kind of fast and it was late and some of you had left. But I wanted to show you this idea of what to do when you're looking for a particular 4 of a kind or a particular flush. It's really an and problem, which we'll talk more about later. It's really an and situation where you multiply some probabilities together. But you can also think about it logically, that you just want 1/4 of these 5,108 hands because only 1/4 of them would be composed of clubs. And then here, you only want 1 out of 13 of those because you only want the ones that have 4s in them, and there's 13 different cards, and you want the ones that just have 4s in them, so you need 1/13 of that, is a good way to think about it.